My name is Johannes Hiltner. I'm product manager for HALCON at MVTec, and it's my pleasure to introduce you in the next 30 minutes approximately how HALCON 13, the new major release of our flagship product HALCON, will help you to automate your industrial processes. MVTec, as a leading manufacturer of standard software for machine vision, not only provides HALCON as a software package, but apart from HALCON, we also provide two other products, which is Merlic, all-in-one and pretty easy to use software. And as a third product, we provide solutions and services which help our customers to, quicker develop their applications, provide third-level support to them, and just to enable their machine vision applications. So HALCON 13, the new major version of our flagship product, has been released on November 1. So it's already 7 days. It's actually exactly 1 week from now we released HALCON 13. And HALCON 13 comes with a lot of major improvements, and one major improvement is in the area of segmentation. Segmentation is a topic in industrial machine vision which can be quite challenging. It's a very basic task, but, those of you who know machine vision, they know that a simple threshold operation in not all of the cases solves the final application. So that's why we focus a lot on pretty challenging segmentation problems. And one feature which we implemented in HALCON 13 is the so-called MSER. It's called the maximally stable extremal regions, and this one allows us to easily segment regions with homogeneous gray values in front of cluttered background. So this is an application from the agriculture industry, but HALCON is not only used in agriculture industry, but also in typical electronics and automotive industries. And this MSER algorithm is also capable of segmenting regions with low contrast, on the one side with sharp edges, but also with soft edges. So with a very simple MSER segmentation call, with this one operator within the HALCON library, this one allows us to now more easily segment even challenging segmentation tasks. Another topic when it comes to segmentation is texture. When analyzing textures, it's always a very challenging task because texture, they have various shapes, various gray values, various illuminations. Texture may occur in orientations and very, very strange situations. And one task is to find defect on these textures. And with HALCON 13, we introduced an easy-to-use texture inspection. And this one allows us to, with a very simple operator call, to find defects in pretty challenging texture environments. So this is a typical application. I think this is an application where we see wool, and by simply passing we need at least one training image. Without one training image might be too difficult, I guess, but at least one image between 2 to 5 training images of a good sample. With this easy-to-use texture inspection approach, we are now able to find these kind of defects. So this is an application from the wool industry, but also for the automotive industry, inspecting texture of metal surfaces, for example, locating defects on metal surfaces. And as I mentioned, it's not only locating texture defects, but we put a huge focus on the ease of use of these algorithms. And this is just a few operator calls which are needed in order to apply the texture inspection model to an image. So it's a handle-based approach. Those of you who know HALCON already, they know that a handle approach is a quite, easy way of handling data within HALCON. So we just create the texture inspection model, and by adding the second operator from the top, we add good samples of our texture into the handle, and then by just simply training this whole texture inspection approach in the background, there's a GMM classifier So it comes with a lot of predefined features which allow us to easily identify these kind of defects in correspondence with a novelty detector, and then by simply applying the texture inspection model to these kind of pre-trained GMM classifiers, these just result then in these segmented regions. So this one can be used on the one hand to locate defects, to segment defects, but not only to segment defects, but, well, other regions of interest, for example. And this is a pretty funny application which we solved the last couple of days. This is this aluminium foil from chocolates, from the Lindt chocolate. So on the left side, these yellow rectangles we used as training samples for our texture inspection model. And so the texture inspection model now knows how the background texture actually looks like, and all gray value changes within these background texture, they are now segmented as a defect class, so to say. But this defect class can also be used for further inspection tasks, like doing OCR on embossed text on metal surfaces, or in this case, for example, to segment where the logo is printed and do further print inspection, for example. Then another big focus with HALCON always is the 3D topic. And again, with HALCON 13, we set up the measurement for 3D quite high. 3D reconstruction is a very important topic when it comes to 3D image processing, and there's a huge variety of 3D reconstruction technologies available. And one of them is stereo reconstruction. With HALCON 10, nearly 4 years ago, we introduced the so-called multi-view stereo reconstruction, which allowed us to use multiple cameras, not just 2 stereo cameras, but multiple cameras to do 3D reconstruction. The downside of this approach was that even though we used multiple cameras, we only used stereo image pairs to do the stereo reconstruction. And this resulted in multiple point clouds, which were put just blindly together. But now with HALCON 13, we use this whole information from multiple cameras and use a technology called sensor fusion from multiple cameras. And this one results into very high quality 3D point clouds. So the benefits are noise reduction, for example, very important outlier suppressions. When you take a look at 3D reconstruction point clouds, there's always the problems of noisy data, outliers flying around somewhere in the 3D space. There's an even subsampling now, hole filling, and also high quality triangulation. So this is just a very simple example of combining 3 cameras to do high precision, high quality 3D reconstruction. Well, all these very nice benefits, they come with a cost, of course. So this approach is more computationally intensive than the other approaches we implemented so far. So that's why we think that this is not actually usable in an inline inspection process, but for an offline reconstruction, for doing, let's say, 3D printing, high quality reconstruction of reverse engineering, for example. So this is just another pretty nice example of how high quality these point clouds look like. We can even use the color mapping from color cameras in order to reconstruct colored 3D point clouds. Might be usable for 3D printing, for example. Those of you who know HALCON, they also know surface-based 3D matching. Surface-based 3D matching also has been introduced with HALCON 10, and this one is a very, very powerful position recognition technology which allows us to determine the exact 3D position of objects within 3D point clouds. The benefits are it's quite a robust technology. It uses surface points and their corresponding normal vectors, and as the 3D point clouds contain the full 3D information, this technology is very robust also when it comes to very noisy sensor data. Well, time of flight, for example, is a 3D sensor which is known for highly noisy data and, well, just crappy data, to be honest. And we improved this technology in HALCON 13 in such a way that when handling flat surfaces, this approach had its, downfalls. It had problems to locate flat surfaces like boxes. And now with HALCON 13, we not only use the surface points and the normal vectors of these 3D point clouds to determine the exact 3D position, but there's some very valuable information when it comes to flat objects, which is their edge information. And now, with HALCON 13, we are able to extract this edge information from point clouds. We are able to use this edge information to do a more refined search within the point clouds and are able to more robustly detect especially flat objects. We are not only able to locate the edges from the 3D point cloud, we can also, in addition, use another 2D camera, which are known for their, little noise when it comes to 2D images, but we can also combine 3D sensors with 2D cameras and use the 2D information, the edge information from 2D cameras in correspondence with the point cloud. There's a pretty neat demonstration at our booth, and this shows a small augmented reality application where we locate the small sitting boxes located in front of a Basler time-of-flight camera. So, HALCON customers, they know what they're doing. They do pretty awesome applications. They do programming and pretty in-depth analysis. And we also focus on these guys who just know what they're doing on developing applications. And there's one pretty neat improvement in HALCON 13. And in order to explain you this pretty neat feature, I want to show you how most of our customers develop their machine vision applications. So on the top left, there's HDevelop. HDevelop is our integrated development environment, which allows our customers to do, rapid prototyping, trying out different approaches, combining different approaches. And then after solving the machine vision part within HDevelop, most of our customers use the code export function. So there's a magic button within HDevelop. You click that button, and then this script-like language, which has been very easily developed in HDevelop, can then be exported into the programming language of your choice, which might be C, C++, C#, Visual Basic. And then from there, within Visual Studio, for example, they add the graphical user interface, the machine vision, the machine interaction, for example, and then compile the application to the final application which runs on the machine. So this is one way of developing an application. There's another way, we call it the smart way. And the smart way means that, of course, we still start with HDevelop because this is our rapid prototyping tool. And now, without exporting the code into C++, without compiling the code into the final application, we use that HDevelop script and directly interpret this HDevelop script within our final application. Sounds awesome. It is awesome, but the interesting thing is that this feature has been in HALCON since HALCON version 8. 1 week ago, we released HALCON version 13, so I think it's over 12 years ago that we introduced this feature. And now there's a big improvement when it comes to this usage of HDevEngine within our application, because now we can also debug the HDevelop script, which is being executed within this final application, within this executable. We just connect HDevelop from any location, from any remote location, to that HDevEngine application. This might be a smart camera connected to your laptop. This might be on the factory floor somewhere overseas, for example. You just connect your development PC, which runs HDevelop with a development license, onto this final application, which runs the HDevEngine code, and you're then able to debug, to analyze what's actually happening within this HDevelop code, which runs within this final application. So this is, for those of you who program within HDevelop, who use smart cameras, they will love this feature. I do. It's pretty nice. Well, then with HALCON 13, there's one other major topic, which especially within the context of Industry 4.0, Industrial Internet of Things, is the identification of objects. And objects can be identified in various ways. Barcodes and data codes is one way of that. And again, with HALCON 13, we introduced major improvements for these kind of code types. So for barcodes, for example, we can now even read barcodes which nobody wants to read anymore. So by combining the scan lines of different heights within the barcode, we are now able to read barcodes which look pretty defective. One of our Japanese customers once told me, you need to read barcode even if it's not there. It is difficult, but we try our best. So from the barcode point of view, but also from the data code point of view, and the QR code, for example, is very commonly used in the Asian regions. And we, again, with HALCON 13, improved the QR code in terms of perspective distortions for highly blurred images for movement blur or out of focus, for example. Irregular grid, which comes from printed QR code where the printing speed changes, so this grid irregularity, and also for low contrast images. But not only for QR codes, the ECC 200 code is also quite commonly used data code. And since HALCON version 9, which is now already 6 years ago, 8 years ago already, we are able to even read ECC 200 codes which have a damaged finder pattern. And damaged finder pattern means, for example, this lower border, this changing finder pattern. And so finding these ECC 200 codes has been introduced many years ago. Since a couple of months, there's competitors who say, well, we want to read ECC 200 codes even if there's no finder pattern at all. Well, to be honest, this doesn't make a lot of sense because a finder pattern is there to find the code to be read, right? Well, anyway, we can now also do that, reading ECC 200 codes even if there's no finder pattern at all, missing finder pattern. Another topic when it comes to identification is OCR, optical character recognition. And since various HALCON versions, we try to make optical character recognition as easy for our customers as possible. And this means that we introduced a new operator which is called find text. And this find text operator, well, it actually does what it says. It finds text for you. So it's an automatic segmentation approach for text. And we enhanced this find text operator in terms of also finding more challenging text, for example, dot print text. And here again, the focus is on the ease of use of these kind of pretty complex technologies. So by just creating your text model reader, you can either set the parameter that you're interested in reading dot print, or you can also keep it with the default parameters. And just by calling the operator find text, this operator not only segments the character, so it not only locates the character regions within the images, but it also does the classification for you. Speaking of classification, so there's two steps, segmentation, and then there's the classification. And from the classification point of view, there's various classifiers available within HALCON. The MLP classifier, the multi-layer perceptron, the support vector machine classifiers. There's a huge range of classifiers which can be used for classifying characters. With HALCON 13, we introduce a new classifier, and this new classifier is based on deep learning technology. It's based on convolutional neural networks, and for that we used hundreds of thousands of sample images to optimize this neural network. So we put all these hundreds of thousands of samples into a big brain. I saw this big brain today already by other companies who try their first steps with deep learning. And then this deep learning approach, it automatically extracts features to automatically differentiate between those many different classes which we see from OCR applications. So all this talking sounds nice, but we want to know how good this deep learning actually is. And we did a pretty challenging evaluation benchmark. So we not only picked up some OCR samples, but we really picked up challenging OCR samples. And comparing to a regular testing data set, which, well, only contains similar images belonging to a similar application, we picked up over 1,000 images from many different kind of applications, and we labeled over 80,000 characters. So they were sitting, some students, working students, days for days, weeks for weeks, labeling and sampling our training data set. And when you take a look at these images, you will recognize that, well, even me as a human, I have my problems reading one or the other character. So the following slides, I will show you the error rate which we had when applying our HALCON 12 MLP classifier and comparing this to our HALCON 13 deep learning classifier. And the error rate means wrongly classified characters. And you now would say, wait, well, this is a marketing presentation, so I expect that CNN, deep learning, is able to read 100%, right? Well, to be honest, not with this kind of data set. It's a pretty challenging data set. It's not optimized for any application. And yeah, just shoot it out. What are the results? There's 3 results. One result is for any kind of character, digits, characters, and special characters, like the character set here from the bottom. And with HALCON 12, we had a false recognition rate of 18.5%. And with HALCON 13, with our deep learning classifiers, we minimized this down to 13%, which is approximately 50% better reading rate than the HALCON version before with the old multi-layer perceptron classifier. When taking a closer look at digits and characters only, we are now extracting all the special characters from our test data set. With HALCON 12, with our MLP approach, with our old approach, we had a wrong classification rate of 10%. With our CNN technology, we reduced that to 6.1%, which is nearly twice the recognition rate than we had before. And we did a similar test with digits only, which is mostly used in typical expiration date applications. And here we reduced the error rate from 4.2% down to 2.6%. So it's nearly double the recognition rate than the old classification approach. So this shows that we know deep learning. We did a lot of evaluations, a lot of tests, a lot of research and development for deep learning, and we figured that what is the most important application when it comes to industrial industry. So we figured that OCR would be the first step. But we continue to work with deep learning technologies and be tuned for the next couple of months, the next couple of years. There will be even more deep learning technologies available within HALCON. So then there's the last topic, and in my opinion, one of the most important topics when it comes to industrial machine vision, which is Speedup. In upcoming industrial applications, we need to have a higher throughput, we need to have better inspection, more robust inspection, faster inspection. And with HALCON 13, we gained an average speed up by 14% on Windows architectures, Windows operating systems. We did this, well, by making use of AVX2 compatible instruction sets, which are introduced with all newer Intel processing units. And this is the average. So there's operators which are ways faster than just plus 14%. There's operators which don't get a big leap in performance, but this is the average speed up. For Linux operating systems, this average speed up is 18%, 18%. So by just recompiling your application based on HALCON 12 with HALCON 13, you might get an average speed of 14%. And I want to point out one specific technology, which is a very basic technology again, which is used in, well, I would say at least 80% of industrial applications, which is shape-based matching. So a contour-based algorithm to locate objects in 2D space. And with shape-based matching, we make extensive use of AVX2 instruction sets for newer Intel architectures. And with shape-based matching, we gained a speed up of up to 300%. And this is a huge speed up, as shape-based matching is a very important and basic technology which is used in hundreds of thousands of applications. So with this speed up, many of our customers will benefit from a huge leap in performance again. So thanks for your time. I also want to invite you to visit us at our booth. HALCON 13 is available since November 1st, since 1 week exactly. Our booth is at Hall 1. There's only Hall 1. At E72, it's just a stone stroke over there. And for those of you who are interested in upgrading to HALCON 13, there's a 20% discount on any SDKs beginning from November 1 until December 9. So everyone who purchases a new HALCON 13 SDK or upgrades to their existing HALCON 10, 11, 12 SDK to HALCON 13 will benefit from a 20% discount. Thank you very much for your attention, and I'll be here the whole week, also here directly after my speech. I'm happy to talk to you. If there's any question, please just come up front, and I'm happy to answer all of your questions. Thank you very much.